Everyone, and welcome to my YouTube channel. So here today we are going to be looking at an introduction to reactions in Aqueous. So most of these reactions will be occurring in a solvent. Now the solvent that we are going to be looking at is water. Now water is a solvent. So a solvent by definition is defined as a liquid in which a solute dissolves. And a solute is a substance that dissolves in a solvent. Let's look at the structure of water and how it looks and how it is able to dissolve other substances. So we can look at water. So now we know that the formula of water is H2O. And now what goes on is that we have oxygen there. Then bonded to it is hydrogen. It has got a bent structure, so that's why the structure looks like that. Though we are going to look at it further when we look at chemical bonding. So now recall that these are non-metals, and oxygen has got the valency of 6. Hydrogen has got the valency, that is the valence electrons, those electrons that are found in the outermost shell. For oxygen it has got 6 and hydrogen has got 1. Now due to the fact that when these two combine, so we have another hydrogen there, when these two combine, you will find that due to the fact that oxygen has more like gained or has more electrons in the outermost shell, it attains a partial negative charge. You can just think of it as the same idea where if you're contributing with people, the more you put in, the more you are going to get a share of. Now if oxygen is contributing more electrons, it means to say it shall have a partial negative, and then our hydrogen will have a partial positive. So in other words, we say that hydrogen, or rather oxygen, has got a partial negative, or rather it is more electronegative. So let's define what electronegativity is. It is simply the ability of an atom to attract electrons. So now when you compare the electronegativity of hydrogen and oxygen, oxygen has got the tendency of gaining more electrons, or rather it effectively attracts electrons. So this is what we refer to as electronegativity. So now oxygen is more electronegative, meaning to say it has got the tendency of gaining more electrons, or it strongly attracts electrons in comparison with hydrogen. If you recall, we also learned that hydrogen may sometimes behave as a metal where it donates electrons. But remember, the partial negative and the partial positive, we introduce this term because when non-metals bond, instead of giving their electrons, they share their electrons. So now for oxygen, it is partial negative because of its tendency to attract more electrons. It's more like it has got more electrons in comparison to this one when they bond. Now when you look at the partial positive, we are referring to atoms that loses some electron density. This means to say, in other words, they are the ones that more like act as the positively charged, because for them they are not attracting electrons as effective as the partial negative. So partial negative, it is assigned to atoms that attract electrons more. So in our example for water, we have oxygen is more partial negative, meaning to say that's got the tendency of attracting more electrons towards itself. Then we have the hydrogen like that, then it will be like that. So that's the way it is. Hydrogen will more like have a partial positive like that, So this is what we refer to as partial negative. If you look at the elements in which hydrogen is bonded to fluorine, fluorine tends to become more partial negative, meaning to say it attracts more electrons in comparison with hydrogen like that. So this is basically what we refer to as electronegativity. Now let's look at hydration of ionic substances. So ionic substances are simply substances that are made of a metal and a non-metal. For example, we might have an ionic substance such as sodium chloride. So sodium is a metal, chlorine is a non-metal. So this is an ionic substance. So how does water dissolve such a substance? It is through the attraction. So if you look at the sodium, since sodium is positive, it is attracted towards the oxygen, which is partially negative. So now what begins to happen is that we have when it's dissolved, we have sodium separated like that. Then chlorine, it will go to the positive. Since chlorine has got a negative charge like that, then it will be attracted to that. Now this attraction is just like the attraction between two different genders. So the positive will be attracted to the negative, and the negative will be attracted to the positive, like that. So this is how substances are able to be dissolved. Now, due to the fact that they are separated, we can simply say that they will now occur in a dissolved state because they are separated from each other. So that's the way it works. So yeah, so the positively charged ion, an ion is just a charged substance. Now a positively charged ion, which is also known as a cation, attracts to the partial negative. In this case, our partial negative in water is just oxygen. Now the partial negative ion, let's say the chlorine in that case, is able to be attracted to the partial positive. So the partial positive in this case, it is attracted to the hydrogen in water. So now that is how water is able to dissolve substances, by this attraction. Now what you must know is that water itself is a polar substance. So what we mean by a polar substance is that it has got an equal distribution of electrons. Remember, when we defined the partial negative and the partial positive, we are looking at which one has more electrons. Now due to that thing, you will find that we have a polar substance, a substance that has got an even distribution of electrons. The electrons are not evenly or equally distributed. So that is what we call polar substances. Now water is not only able to dissolve ionic substances, which we looked at, but it is also able to dissolve other polar substances. So under this one, the approach is the same. So they dissolve polar substances. Now remember, polar substances must also have a partial negative and a partial positive. So if we have high oxygen there with an S negative, hydrogen there with an S positive, we have hydrogen there with an S positive. So now what this means is that for polar substances, they also have this type of a structure. The example that we might have is ethanol, which is alcohol. We might also look at ethanoic acid. If you recall, the formula is this for ethanoic acid. So as you can see, this is fully non-metal, so it's a polar substance that is able to dissolve in water. We might also have another polar substance such as sugar. So now the way it is that the approach is the same. The partial negative is attracted to the partial positive, and the partial negative or the partial positive is attracted to the partial negative. So that's the way it is. Now in any element, since whatever moves is now separated, that is what causes the materials to be able to dissolve. So that is how polar substances are dissolved. We are going to find that the partial negative, the one with the S negative, will be attracted to the partial negative, and vice versa. So if we have the partial positive here, it will go to the partial negative of water, which is our oxygen. Likewise, the partial negative will be able to be attracted to our positive part of the molecule, like that. So this is how water is able to dissolve substances such as polar and ionic substances. Now the rule of dissolving is about like dissolves in like substances. Now this is important because there are some substances which water does not dissolve. So water dissolves substances such as, let's look at these substances. It dissolves polar, which we have talked about, and ionic substances. The substances that water does not dissolve, we have water doesn't dissolve non-polar substances. So under non-polar substances, electrons are mostly shared equally between atoms. Example, we might have example of substances. We might be looking at fats. Fats do not dissolve in water. That's an example of non-polar sub. So firstly, water doesn't dissolve non-polar substances. So example we might have is fats. So what is able to dissolve fats is another non-polar substance, such as petrol. So petrol is also a solvent, which means it's a liquid that can be able to dissolve other non-polar substances such as fats. So that is the introduction to reactions in aqueous solution. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.